Today we'll be doing the integral from 0 to infinity of e raised to the negative x squared power times dx. And start off, we could call this integral I, and we could square both sides. So we have I squared equals the integral from 0 to infinity times the integral from 0 to infinity of e to the negative x squared times e raised to the minus y squared dx dy. We could combine those by the property of exponents. So we have I squared is the integral from 0 to infinity and the integral from 0 to infinity of e raised to the negative x squared minus y squared power dx dy. And now we could factor out a negative from the exponent. So we have I squared equals the integral from 0 to infinity and the integral from 0 to infinity of e to the negative x squared plus y squared dx dy, and x squared plus y squared is equal to r squared, and dx dy is r dr d theta in polar coordinates. And we could visualize this as the graph of e raised to the negative x squared power. So it's going from 0 to infinity in the x direction, but in the y direction it's going to go from 0 to pi over 2. So therefore we could say I squared is the integral from 0 to pi over 2, and then the integral from 0 to infinity of e to the minus r squared, r dr d theta. We could employ a substitution. So I'll let gamma equal to r squared, which tells us that d gamma over 2r is dr. So I squared is the integral from 0 to pi over 2, and the integral from 0 to infinity of e to the minus gamma, and then it's going to be r times d gamma over 2r d theta. The r's will cancel, and we're left with I squared equals 1/2 the integral from 0 to pi over 2 times the integral from 0 to infinity of e to the negative gamma d theta. And now we just have to evaluate this inner integral. So we have I squared is 1/2 the integral from 0 to pi over 2. This integral will be negative e to the negative gamma. I've evaluated this from 0 to infinity. I'm going to put the negative in front of the integral sign. So you have I squared is negative 1/2 integral from 0 to pi over 2 of e to negative gamma, where I've been valuing this from 0 to infinity, d theta. So I squared is negative 1/2 integral from 0 to pi over 2 of the limit as gamma approaches infinity of e to negative gamma minus e to negative 0 d theta. So this clearly goes to 1. We have I squared equals negative 1/2 integral from 0 to pi over 2. And this limit, as the gamma approaches infinity, would clearly go to 0. So we have negative 1 times d theta, but the negatives will cancel. So we have I squared is 1/2 the integral from 0 to pi over 2 of d theta. So then we have I squared is 1/2. The integral is going to be theta from 0 to pi over 2. But that's just going to be 1/2 pi over 2 minus 0, which is pi over 4. So now we have I squared is pi over 4. So we could take the square root. I equals plus or minus the square root of pi over 4. But that's plus or minus the square root of pi over 2. And we'll only take the positive part because it's positive area. So we have I equals the square root of pi over 2, which is our original integral, the integral from 0 to infinity of e raised to the negative x squared power dx. And that is the final result. Thank you for watching.